Hi everybody. So this video is a continuation of the last one where I show how to apply Newton Ralphson's method to finance. And in this video, I'm going to be looking at credit default swap spreads. So I have my shell script right here, which is going to execute and compile the credit.cpp file. So I'm going to go ahead and exit that. And then I have the formulas that I need for the premium leg and the protection leg. Premium's the buyer, protection's the seller. And I'm going to use the axes 1 minus recovery rate, and then the default rate as my x and y axes. So let me import some libraries. So include IO stream, include vector, include python.h, and include math.h. I think this should be good. So I'm going to define my main function, return 0. Oh yeah, I forgot. I also have to include matplotlibcpp.h created by the username lava, and I'm going to come here and do namespace plt equals matplotlibcpp to simplify like calling the different libraries. So I'm going to first come here and define some parameters. So I'm going to do notional equals $1 million. I'm going to define time as t, and it's going to be 30 days. So 30 divided by 365.0. And then I'm going to define the, well, actually, yeah, let me go ahead and define these two vectors. So the first one is going to be probability, and I'm gonna, so this is the no, I'm trying to think how I should do this. I need the default rates and the recovery rates. So I'll actually call this default rates. So that's going to be 0 0.01, 0 0.02, 0 0.03, 0 0.04, 5, 6, 7, 8, 9, 10. Okay. And now I'm going to define the recovery rates. And that's going to be 0.1, 0.2, 3, 4, 5, 6, 7, 8, 9, and 1.0. So for this, I have to do 1 minus the recovery rate for each option. So that's going to be for int I equals 0. I is less than recovery rates dot size plus I. So it's going to be recovery rates of I equals recovery rates of I minus oh no, 1 minus the recovery rate. So 1 minus. Okay, so now I got that settled. What I have to do now is convert these into grids. So before I even do anything, I'm going to come up here and do a transpose function. Get this out of the way. Transpose x. You guys have seen me code this so much in these videos that it's like, it's muscle memory at this point. So for int I equals 0, I is less than x 0 dot size plus I temp dot clear. I've been programmed to program this. It's so easy though, it's just like reversing the dimensions. So So that's going to be x of j of I, and then z dot pushback temp, and then return z. So what I need this for now is I need to declare two vectors. X and y, and then for int I equals 0, I is less than, they're both the same, so I'll just keep it at 10, or rather I'll just do default rates dot size. Plus plus I, let me think, so the default rates have to be, cumulative, no, the recovery rates I think are good, oh yeah, the default rates do have to be cumulative, so that's going to be, we're gonna have to create a separate function for that. It's gonna be 1 minus, okay, yeah, I'm just gonna create a vector function. I'm gonna call it reverse vector double x vector double res and return res. So that'll be, for default rates, it'll be double product equals 1.0, res dot pushback 1.0, because that's going to be the initial. So yeah, these dimensions are actually going to have to change a little bit. Yeah, so it's going to be for int I equals 0. I is less than x dot size plus plus I. So it's going to be product times equals 1 minus x of I. And then it's going to be res dot pushback product. And that's going to return the reverse. So what I'm going to do is I'm going to print these out. So I'm going to come here and honestly, let me just get rid of this right now. Let me do for auto R in reverse of default rates. See out. Oh wait, I hate when that happens. Okay, so I'm gonna come here and do ./credit.sh. Hopefully I don't have any errors in it. So it's compiling. I just opened up the terminal, so that's probably why it's like, oh, there's two warnings. Okay, good. So ./a.out. Perfect. Okay, this is looking good. So what I'm gonna do is, in order to keep this at the same size, I'm going to actually cut off one of them. So instead of 10% for the default rates, I'll just keep it at 9. So yeah, this will adjust. So yeah, now we're good to go. I'm going to come here, cut this out, and then I'm going to put default rates equals reverse. So now we have these. So now time to make the grid. So that's just going to be for int I equals 0. I is less than default rates. Or just make sure it's, yeah. So Okay, good. So default rates dot size plus I. So that'll be x dot pushback. So what's our x-axis going to be? LGD, which is 1 minus the recovery rate. So I'll do recovery rates of I. Oh, no, I don't even need to do of I. I'll just do this. So y dot pushback default rates. So now I'm going to come here and do y equals transpose of y to make it grid-like. And then I'm going to, so I have the inputs. So it'll be for int I equals 0, I is less than x dot size, plus I. For int j equals 0, j is less than x0 dot size, plus j. So now I'm going to come over here and create some functions. So I'm going to call this premium leg, and it takes the argument of notional, CDS spread, credit default swap spread, DT. Let me make sure we got DT in here. So let me minimize this. Okay, so int n is going to equal 50. So double dt is going to be t divided by cast double n. So yeah, now we have dt, and then we need r. So let me do double dt, double r, and I think we're good to go for this function. Let me just make sure I have r. Nope, so that's going to be double r equals the power of 1 plus 0.0548 to the power of 1 divided by 30. This is the 30-day treasury rate, not 30-year. The 30-day is higher than the 30-year, though, which is pretty scary. But yeah, so this is going to be our risk-free rate. I'll just call it RF to denote that. So what I got to do now is come back here and do return. No. This is going to be a summation. So double PV for present value is going to be for int I equals 0. I forgot here the n. So I is less than n plus I. So it'll be PV plus equals notional times CDS times DT divided by the power of 1 plus R to the I plus 1, so it doesn't equal 0. And then we're going to return PV. Okay, so that's our premium leg equation. Now our protection leg equation will be this. Protection leg, so that's also going to take notional. It's going to take LGD. It's going to take a vector of probability. I'll leave that for last. I'll do double R, and this will be vector double probabilities. I'll call it PV. Okay, so let me make sure that I have, let's see what exactly is going to go into this. So LGD is the recovery rates, and then PB is the default probability. Okay, so this will be pretty straightforward. Double PV equals 0. So that'll be 4 int I equals 0. I is less than PB dot size plus I. So that'll be, what's the formula? PV plus equals notional times LGD times PB of I divided by the power of 1 plus R to the I plus 1. And we're going to return PV. Okay, so let me make sure I have all the dimensions correct. So it's going to be So J is there. Oh, okay. So I'll do double LGD equals um, Y, no, X of IJ, and then we're going to be pushing the whole vector of PB. I'll just declare it in here. So vector double PB equals um, the default rates. So that's going to be Y of I. So for each iteration, it's going to do that. And then, so we have that. Oh, now I could, so what I'm going to do is take the derivative with respect to CDS. So it's not going to be much of a change. I'll just control C this, control V. I'll call this D premium leg. And all I have to do is just take out the CDS and the calculation will work. So now I have these three. I'm going to create a function called calculate CPS. So calculate CPS, no, CDS. So this is, so now is where it gets a little tricky with the inputs. So we're going to have notional as an argument. We're going to have LGD as an argument. We're going to have DT as an argument, R as an argument, N as an argument, and the vector of the probabilities, PB as an argument. So I'm going to declare some initial parameters. So I'll call this CDS 0 equals 0.01 and CDS 1 equals 0.99. And then while true, CDS 1 equals CDS 0 minus so premium leg of notional CDS 0. Yeah, this is the Newton Ralphson's method being applied here. So DT, R, and N minus the protection leg. So that'll be notional LGD, R, and PB passed as the whole vector divided by D premium of the legs. So that'll be notional DT, R, and N. I don't need to include CDS in this because there is no, like we'll double check it right now. There's no CDS variable in here. It's the derivative. So now that we have this, we come here and do if the absolute value, I'll do F absolute of CDS1 minus CDS0 is less than or equal to 0.12341 is going to break the loop. But then it's going to also recursively iterate, so CDS0 equals CDS1. And then outside of here, I'm just going to return CDS1. So we have calculate CDS. So now let's look at what this looks like. Just to simplify things to move faster, I'll copy this. I'll come in here. So this will be, do I have notional up here? Yeah, I have notional. I have LGD, I have DT, I have R, well, no, it's called RF, I have N, and I have PB. Yep, PB's right here. So, now to close that off, I'm going to do double result, no, I'll do calculation. And I'm going to print this out, so that'll be cout calculation. Okay, so now I'm going to come here and do ./credit.sh. It's going to give me some warnings. Okay, good, no errors. So that'll be ./a.out. Okay, this is weird. It's returning me a 0 at some points. Yeah, it's at the end of each row. I gotta figure out why it's doing that. Yeah, why is there a 0 printing out? Maybe we have to. Oh, actually, we could just make this the recovery rate. So let me cancel that out. Compile credit.sh reset ./a.out. Okay, now it fixed itself. Okay, so now we can plot the data. So now let's just create some vectors around that. So it'll be, we're really just solving for one. So it'll be, I'll come up here, do z, and then I will do I have a temporary vector over here somewhere? No, I don't. But I can declare it here. So vector double temp. So then that'll be temp dot clear. Temp dot pushback calculation, and then z dot pushback temp. Okay, so now let's see what this looks like. Well, actually, before I do anything, I'm going to come to matplotlibcpp.h, and I'm going to make axes names for it. So this will be, I'll put it right under here. So inline void chart 3D axes names. So it's going to take pi object ax, and then it's going to be pi object. So it's ax x-axis. So it's going to be pi object get attr string ax set x label pi object y-axis equals pi object get attr string ax set y label, and then pi object z-axis equals pi object get attr string ax set z label. So I'm gonna need some strings in here for the labels, so that'll be string x, string y, and string z. So I'm gonna define a pi object of args equals pi tuple new of 1. So it's going to do pi tuple set item args 0 pi unit code from string of x.c underscore str, and pi object call object of x-axis args. I'm going to do the same thing, but this time it'll be y and z. And also I got to remember to change them here. So y-axis and z-axis. Okay, so I think we're good to go. So it'll be pi object ax equals plt chart 111 plt, what did I call it? Terrible short-term memory. Chart 3D axes names. Chart 3D axes names ax. So the x-axis is going to be the recovery rate. So I'll just do 1 minus, or rather, is there a Oh, actually, instead of even doing that 1 minus recovery rate, I can pretty much just reverse these. So that'll be reverse recovery rates dot begin, recovery rates dot end. So yeah, that should do the trick to that. Okay, so the x-axis is going to be 1 minus recovery rate. The y-axis is going to be, do I have it up here? Oh, actually, I'll just call this LGD, and then the y-axis will be called default, or no, probability, and then the z-axis is going to be CDS spread. Okay, so now I could do PLT surface 3D map, and it's going to be AX, X, Y, Z, jet 1.0, and then PLT show. So let me come over here and compile this again. So credit.sh, reset, /a.out. Okay, so we have it. So the LGD, the probability, and the credit default swap spread. So this is what it looks like for 30 days. So as we can see, as the LGD gets higher, or like as the recovery rate gets lower, the spread increases. As the probability gets higher, the probability of default gets higher, the spread increases. And yeah, that's about that. So what I'm going to do is I'm going to animate this plot. So I'm going to exit here. I'm going to come up to where I have time. So I'm going to declare a new vector. So that'll be vector double the time equals, so 30 days, 60 days, 90 days, 120 days, 150 days, 180 days, and 210 days. So let's see how this performs. So I'm going to come here. So where I have t over here, I'm going to put like a, well, this is going to go outside of this loop. So I got to come back here and do this. And then it's going to be for auto TS in the time. So we're going to see how the spread reacts over time as time is increased. So I come here, close that off. I will do PLT pause for 1 second so we can see how this works and then show the plot. But I've got to come back up here first and do T equals TS divided by 365. So I'm going to come here and do credit.sh, reset, /a.out. Okay, so we could see that as time progresses, the credit is lowered, as we can see here, but the patterns remain the same, but it's just like as time progresses, we don't really have an urge to have like a huge spread to like account for. But yeah, that's pretty much it. This is the credit default spot spread rate in C++, and I hope y'all enjoyed watching this video. We'll keep coming out with more, so stay tuned. Peace out.